The strong force and my model. The strong force holds quarks together to form protons and neutrons. The nuclear force holds protons and neutrons together in the nucleus of the atom. But the major problem with the strong force as it is now is that it does not yet connect with the electroweak or gravity. This post suggests a solution. Please see my other post for much more. First, my model replaces the 3 quarks with a set of 3 particles, 1 electron and 2 positrons. These were made through pair conversion in the Big Bang. My model of the proton, then, is made up not of 3 quarks, but of 2 positrons and 1 electron. The 2 positrons are in an orbital. The 2 positrons have opposite spin, which adds to their stability. The electron is in the center. Together, the 2 positrons and 1 electron add up to an exactly positive charge 1. The same charge as an electron at -1, though their masses are very different. My model of the neutron is the same as the proton, but with an additional electron. Total charge is 0. The neutron is a proton plus an electron. First, the nuclear force. See top of drawing. The proton is on the left and the neutron, a proton with an added electron, is on the right. The force holding the proton and neutron together is clear. It is that extra electron of the neutron. It acts like a binding glue to hold the proton and neutron together. That is why every atom nucleus after hydrogen needs neutrons. They bind the neutron to the proton through the electromagnetic force, strong force. First, some facts. The free neutron outside of the nucleus decays in 10 minutes into an electron, a proton, and an antineutrino. But the proton is extremely stable and does not seem to decay at all, if ever. Next, we know that these things about the strong force. It is very strong, 100 times stronger than the electromagnetic force. It gets stronger, like a rubber band, the more the proton is stretched apart or scattered. The resistance of the strong force increases up to the distance of the diameter of a proton. Look at my drawing, bottom. This explains those facts about the strong force. The structure of the proton, with an orbital of 2 positrons around an electron in the center, is so stable that the proton has lasted since they were made in the Big Bang. That was why protons survived the electron-positron annihilation phase and were left in small amounts to make all atoms. That is also where all the missing antimatter or positrons went, and why there are no free positrons found today. They were used up to make protons at the start of the universe. The proton is virtually so stable it cannot be broken. Trying to stretch the proton's outside positron ring makes a massive resistance that increases the more it is stretched. This is much like stretching a rubber band. This is the reason for the strong force. Remember, the present-day evidence for quarks is proton-proton collisions that make quarks. But those immediately turn into mesons that turn into electrons, photons, and neutrinos. This suggests that if the proton can be broken in high collisions, the positron ring annihilates, leaving an electron plus energy in the form of a photon and neutrino. But that is a big if. The electromagnetic aspect of the inside of a proton must be so strong that it is 100 times stronger than any other electromagnetic attraction.